In this video, I'm going to show you how we can configure multiple route reflector in the scenario in the service provider, and also how we can implement a new feature we call it RR group. Let me first to talk about how we can configuring more than one route reflector. You know that in the service provider we configured in the previous previous video, we configured R9 as our route reflector, and all of the routers R1, R2, R3, R4, and R10 were membered or were enabled with the router 9, and router 9 was the route reflector. But in this scenario, because of redundancy, I'm using two router 13 and router 14 as route reflectors. And also, as you can see, these two routers, R13 and R14, are only the control plane. For example, members means that they are only sending the BGP information to other routers, and we don't need to send the normal traffic, the real traffic from the R13 and R14. This is the off-pass. Route reflector means the route reflector doesn't have any role in the forwarding of data and only it should work as a control plane, for example, function. And after that, we will talk about the BGP RR group. First, we need to configure this scenario. I'm using the configuration of the previous scenario, and with some change, we can do the configuration for this scenario. And after that, we can talk about the BGP route reflector group. This is the configuration of the route reflector, the previous scenario. Let me to change it for the route reflector with RR group. Look at here. Then the route reflector with RR group. I will talk about the function of the RR group, but before that, you should learn about the, for example, configuration of the multiple RR group, multiple route reflector or multiple RR. After that, we can talk about the RR group, and we will learn about this feature. Okay, let me to talk about the configuration. Starting from the router 1, this is the CLI. We can copy the configuration when we completed the, for example, different part of configuration. First, R1. In R1, as you know, we don't have any change. Look at here, R1 again has ETH00. The IP address of this interface is 10.191/24, and also we need one loopback address on the R1, and after that, I enabled OSPF in this scenario. Because we don't have any change in this scenario, I'm going to configure and copy this configuration to the R1. You know that we need to enable IP address on the interfaces, then we need to enable OSPF on that interfaces. This configuration exactly same as the previous scenario. Because of that, I'm going to copy this configuration on the router 1. Okay, this is the router 1. About the router 2, again, we don't have any change. Look at here, we have ETH00 with this IP address, it's okay. And then we have one loopback interface. And after that, we need to enable OSPF. The configuration exactly same with the previous scenario. Because of that, I'm going to copy this configuration, okay, on the router 2. Then in router 3, okay, we don't have we don't have any change. Because of that, let me to copy the configuration. We have one ETH00, loopback 0, and then router OSPF 1 configured. Copy the router 3's configuration on the router 3's CLI. If we have any change, I will talk about that. But until now, we don't have any change. Let me to configure the router 4. In router 4, again, we have ETH00. This is the IP address of the ETH00. Also, we have one loopback interface. And finally, we enabled the OSPF. Everything is same with the previous scenario. Because of that, I'm going to copy this part of configuration on the router 4. That's it. Then we have another router, okay? Another, for example, the router 9. Here, you know that router 9 now has 6 or 7 interfaces. In the previous scenario, we didn't have the R13 and R14. We need to do this change in the router 9. First, ETH00 of the router 9 has the same IP address, 10.199. ETH01 again has the same IP address, this interface, ETH01, 10.299. And then ETH02, this interface has the same IP address, 10.399. And ETH03 has the same IP address, 10499. And after that, ETH10, okay, this interface has the same IP address, 10109. And then we have one loopback interface in the R9. In this scenario, we don't need to configure loopback interface in R9 because I'm not going to configure BGP neighborship in R9. Because of that, let me to remove this loopback interface. Also, we need to enable two new Ethernet interface, ETH11 and ETH12. Let me to copy this part of configuration. Then we need to add ETH11, this is the ETH11, and then 12. After that, we should configure the IP addressing for ETH11. ETH11 has this IP address 10.9.13, then 9, /24, 255.255.255.0. Also, we have ETH12, this interface, with the IP addresses of the 10.9.14, then 9 again. Okay, this is the configuration of the router 9. Also, in router OSPF configuration, we need to remove the loopback IP address from the network statement. Also, we need to add two new network statement, network 10.199, 10.299, 10.399, 10.499, 10.9, 10.9, and after that, we need to add two new statement. Look at here. Let me to copy this part of configuration here. Then the first is the, for example, 10.9.13.9. And the second is 10.9.14.9. This is the configuration of the router 9. Let me to copy this configuration and pasting on the router 9 CLI, copy. And then in the router 9 CLI, we can copy this part of configuration. Okay. Also, we didn't have any error. Also, we need to configure the router 10. The router 10's configuration is same. We have ETH00. Also, we have the loopback 0. Everything is okay. And also, we need to configure OSPF1 on the router 10 as I configured before. Let me to copy this part of configuration and pasting on the router 10. Okay, this is router 10. Also, now we have a new router, router 13. We can copy the router 10 configuration, and after some change, we can use it for the router 13. This is the router 13. Host name is R13, and also we have ETH00. The ETH00's IP address is 10.9.13.13, 255.255.255.0. Also, I enabled OSPF on this interface, and I enabled OSPF point-to-point network type on this interface. Then I enabled this interface. Also, we need one loopback IP address because you know that this is the route reflector, and we need to configuring BGP neighborship in this router. Because of that, we need to configure loopback interface. IP address 192.168.254.13, then quad 255. After that, router OSPF1. This is the router ID 192.168.254.13. Also, the network statement is, for example, 10.9.13.13 quad 0 area 0, and also the network 192.168.254.13. Okay, let me to copy this configuration and pasting on the R13's CLI. Okay, this is the R13 CLI. Let me to find it here. This is R13 CLI. Also, we have another router after copying this. This is the R14 CLI here. Okay, R14 CLI. This is R13. Let me to copy the configuration of R13 first. This is the R13. After that, we can copy the R13 configuration, and after some change, we can use it for R14. This is R14. Here, host name is R14. The IP address of ETH0 is 10.9.14.14, 255.255.255.0. Also, we have one loopback interface, 192.168.254.14, quad 255. Router OSPF1, router ID, 192.168.254.14. Also, the network statement is 10.9.14.14, quad 0 area 0, and the next network statement is 192.168.254.14 quad 0 area 0. Copying this part of configuration and then pasting on the R14. This is the configuration of this router. Now, we expect to see the OSPF neighborship between router 9 and all other routers. Let me check first this condition in R9. I'm using show IP OSPF neighbor. Look at here. We have this neighborship. The router 9 has neighborship with router